All right, so in this lesson, we're going to be estimating large and small numbers with powers of 10. And the way we're going to do that is we're going to basically just rewrite big and small numbers as one number and then multiply by 10 to a certain power. Now, for really big numbers, it'll be 10 to a positive power. And then for really small numbers, it'll be 10 to a negative power. Just as a quick review, we know that if I have 10 times 10 times 10, for example, I can rewrite this as 10 cubed. But if I do 10 times 10 times 10, that's just 1 times 1 times 1, and then 3 zeros. So I would just put 1 times 1 times 1 is 1, and then I just add 3 zeros. And that's my answer. And let's say that I had 10 to the 8th power. I just put a 1, and then I put 8 zeros, because that's the same thing as 10 times 10 times 10, and then 5 more 10s being multiplied. So that's 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, perfect. So 10 to the 8th power is 100 million. Now we can do the same exact string of logic for small numbers. So let's say that I have the number 0.0001, and I want to rewrite this in terms of a power of 10, I should say. So I know that if I multiply by 10, that's the same thing as moving the decimal to the right one. So it'd be multiplied by 10, by 10, by 10, and by 10. Now, moving the decimal to the left is not multiplying by 10, it's dividing by 10. So it'd be divided by 10, divided by 10, divided by 10, divided by 10. So anyway, if you didn't know this already, this number right here is going to be 10 to the negative 4th power. And if you remember, we can rewrite negative powers as 1 over that number with the positive power. So this is the same thing as 1 over 10 to the positive 4th power. And this I can rewrite as 1 over, I'll write it down here, 10 times 10 times 10 times 10, and those are my 4 tens. I can rewrite this again. Well, it's 1, 2, 3, 4 zeros I just have to add on. So this is the same thing as 1 over 10,000. Now you could do 1 divided by 10,000 out, and you would get this exact number, 0.0001. Okay. Now the reason I'm showing you this is one, really, really small numbers, so like numbers with lots of zeros in front of their first non-zero digit after the decimal can be written with negative exponents, and in this case 10 to a negative exponent. So now we're going to do some examples of estimating using some of these types of rounding methods with 10 to a certain power. For this example, we are to round the volume of water on Earth. Write the result as the product of a single digit and a power of 10. Well, down here it says Earth contains about 332,500,000 cubic miles of water. The blue sphere, right here, represents all of the water on Earth relative to the size of the planet, which is remarkably small if you look at this scale. But anyway, what we care about is this number, and we want to write it as a product of a single digit and a power of 10. Okay, so we only care about one digit and then multiply by 10 to some sort of power here. Okay, so the first thing I'm going to do is I'm just going to round this whole number to one digit. So I'm going to rewrite the number. So now rounding this to one digit, I'm just going to go to the first digit, which is a 3. And then I'm going to look at this number, and it is below 5, so it's 4 or below. So I'm going to round down. So I'm just going to rewrite this as 300 million. Okay, now I'll put the commas in for now, just to make this look a little nicer. So anyway, so now this number rounded to one non-zero digit, it's just going to be 3 and then a bunch of zeros at the end. So these zeros are placeholders. Okay, and what I can do is I can break this thing up one more time into 3 times 100 million. And the reason I'm doing this is because I know I can rewrite 100 million as 10 to a power. Okay, so I can rewrite this as 3 times. Now, any number that has a 1 and then zeros after it can be written as 10 to a power. If you move the decimal to the left, all you got to do is figure out how many spaces you move it to get to this 1 right here to figure out what that is 10 to what power. Okay? Another easy way to do it is just count the zeros. So 1, 2, 3, 4, 5, 6, 7, 8 zeros. Or you could go 1, 2, 3, 4, 5, 6, 7, 8. Okay? Either way, we know that this is going to be 10 to the 8th power. I'd probably recommend doing the zero method. Just count the number of zeros once you've broken it down. Okay? So now that we know that this is 10 to the 8th power, and if you do this out, 10 to the 8th power, you are going to get 100 million. Okay? And now it says round the volume of water on Earth, write the result as the product of a single digit into power of 10. Okay? Well, all we got to do is put our unit here. So this is about 3 times 10 to the 8th power cubic miles. And we are done here. Okay, so for this next example, we have a blood vessel has a diameter of 0.0000924 meters. Round the diameter of the blood vessel, write the result as the product of a single digit and a power of 10. So now this one might be a bit trickier because we need to rewrite this as some number times 10 to a power. But if we can tell here, we have a really, really small number, a decimal that has a bunch of zeros after the decimal before its first non-zero number. Okay, so I'm going to rewrite our number. All right, so now I need to figure out what that one single digit is going to be because I'm rounding here. So I'm going to go to just my first non-zero digit, which is a 9 here. And if I go over here, this 2 and this 4 don't matter because I'm going to round them down. Because if you look at the 2, it is less than 5, so I'm going to round down here. So now I can rewrite this, my rounded answer, as 0.00009. So now what I'm going to do is I'm going to break up this 9. I'm basically going to rewrite this as 0.00001 and then times 9. Okay? And the reason I can do this is if I just do 9 times 0.00001, I'm going to get 0.00009. Now I want to figure out what this chunk is to as a power of 10. So the way I'm going to do that is I'm going to move the decimal until I just get 1. Okay? So 1, 2, 3, 4, 5. Okay? So this means that since I moved the decimal to the right 5 times, that means that this number is going to turn into 10 to the negative 5th power. Remember, taking 10 to a negative power makes it really small, and we have a really small number right here. And since I moved the decimal 5 spaces to get to the 1 right here, I know that this is going to be 10 to the negative 5th power. Okay, and then I'm just going to put the 9 times in front of it. So this is going to be 9 times 10 to the negative 5th power, and then we just need our unit. So this is about 9 times 10 to the negative 5th power meters, or of a meter. So this is our final answer. All right, so for this example, we have multiple choice. The distance from Saturn to Neptune is about 1,911,674,960 miles. The distance from Mercury to Neptune is about 1.5 times this distance. What is the approximate distance from Mercury to Neptune? Well, you could just multiply 1.5 times this really big number and then round it, or we could round this really big number first and then multiply by 1.5. So that's what I'm going to do. So I can see, if I zoom in here on this number, this number is really close to 2 billion because this is my first digit, 1, and then 9 is 5 or more, so I can just round this up to 2 billion. So I get 2 billion times 1.5. Well, 1.5 times 2 is 3, and I can just bring all these zeros. So now I want to figure out what this is as a single digit times 10 to a power, because those are my options here. Okay. Well, the quickest way would be to just count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can be rewritten as 3 times 10 to the 9th power. Okay, and if I look at my options here, I know that that answer is going to be answer B. Okay, and if I also did the decimal trick, what I could have done is broken this up into 3 times 1 billion, and then move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get to the 1, to get to a single digit. And then that I know that that is going to give me 10 to the 9th power. So this is going to be 3 times 10 to the 9th power miles, which is choice B here. The population of the Philippines is about 104,260,000, and the population of India is about 1,282,000,000. Approximately how many times greater is the population of India than the population of the Philippines? So since we've been writing all of our really big numbers, or in some cases really small numbers, as a single digit times 10 to a power, that's what I'm going to do here. There's other ways to approximate this, but since that's what we've been doing, this is how I'm going to approximate it in this specific case. So I'm going to rewrite our two numbers. And I see that this is 100 million with some change, but the next digit after the 1 right here is a 0. So this is going to round down to 100 million. And then the Indian population is going to be about 1 billion. Okay, so here's 1. Our first digit is a 1, and then we have a 2, so that's less than 5, so I'm going to round that down. So now I have 1 billion. Okay, so the question asks, approximately how many times greater is the population of India than the population of the Philippines? So that means that I just have to divide India's rounded population by the Philippines' rounded population. So that's going to be 1 billion divided by 100 million. And I can just cross out all of these zeros right here until I'm done. So now I just have 10 divided by 1, which is 10. So we know our number answer is 10, but I'm going to write a word answer as well. India has approximately 10 times as many people as the Philippines. So I've approximated how much larger India's population is compared to the Philippines, and I've written my word answer, so now I'm done.